before we go into the agenda for today, let us quickly look into a way we can generate report from our MATLAB coding exercise. So the last time, I think we saved some script. Did you save any script? Did you save any script?
Yes.
So if you have a script, get the name. Just know what the name is. If you don't have a script, you can click on new script and type some stuff therein. So when you type some stuff inside the new script, save it with a name that is valid. So do you all have a script saved in one of our directories? Do we? So let's assume we have a script and you want to save it maybe in a Word version or PDF version or any version of your choice. For example, maybe shortly you'll be writing test or examination and you need to save your script in a way that you can share with the person that is going to access what you have done so far. So how can we do that? So let's use our guide. So you can use the publish function to generate a report. So into that publish function, what are the things that you are going to put in that? You are going to supply the name of your file. It could be any type of file. So just supply the name of the file. Then you specify the format that you want the report to be in. So let's say, for example, I have a file here called today.m, okay, and I want to save it in Word format. So what I will do is that I will type publish as a function, and inside the parentheses I'm going to put the name, which is today.m, quoted, followed by a comma, then the format. In this case, I want it to be Word document. So the format is DOC, as you can see on my screen. If you want a Word document, it's going to be .doc, okay? So let's see what happens. So in the window command, let's type that. So put in the name of your file and the format that you want. So the format is document. So you can put a semicolon after that command and press enter. Let's see what happens. I'm using doc. You could use any other format. You could use HTML or any other format that comes to your mind. But if you'll be submitting anything that will be accessed by us, we would prefer that you put it in document form, not even PDF. There is a reason for that. So when I click enter, you will notice that a folder dropped under the current folders that are available. So it is inside that folder that whatsoever document that has been generated will be in. So let me give it some time to finish the process so that we could view what is inside that folder. Okay, so I guess the processing should be complete now. So let me move to this directory and see what is in there. Okay. So the process is now complete in my own case. So now I have a Word version of my script, and it's also containing the solution. So let me open it. You can open it and see what is in there. It doesn't matter what type of file you have generated, you can open it so you see what is there. So now I have my works transferred into a Word folder that I can share with people to read. And also the answer that I asked it to display is also being displayed with it. Okay, that's been done. Let me go back to my regular directory. So another thing we will look at before we go to today's lecture is how to write into a file and how to append into a file. So if you want to write or append to a file, the first thing you do is to open the file. And the command to use is fopen. So whatsoever you want to put inside that folder, you use the fprintf to append or to write into the folder. You know, the other time we use fprintf for formatting. So to balance the explanation, I'm just going to show you that you could use that function also to write into a folder and to append to a folder. What does it mean to write to a folder? Now let's say this is a new folder, there is nothing inside of it. So you can be advised to write into it. But if you have something already inside that folder and you want to add more to it, then it's advisable that you use append instead of write. So if you use write, it's just going to overwrite whatsoever is in that file, as if nothing was inside it. But if your intention is not to overwrite what was there, then you use append. But the process is still the same thing. You begin with opening of the file with fopen, then you use fprintf to add whatsoever you want to add into the file, then you close the file with fclose. So let's see an example of how the syntax works. So here we have, let's say, variable day 1 that we call Monday, variable day 2 we call Friday, another variable t1, let's call it 9, t2 we call it 12 point that. So we have that. So let's say we want to write that inside a file. If the name of the file is called lecture days and we want it to be in text format, it could have been any format, but let's say this time around we want it to be a text format, so that's why we have .txt. So we want to write all of that inside a file. So to write, you use W as the permission. So you are telling, when you put W inside quotation, you are telling it that, okay, what I want you to do with this file that I've opened is that you write into it. So what am I writing? So this is what the fprintf lines talks about. So the first part of it is, where am I writing into? I'm writing into a variable LEC. I've created that in the previous line. So LEC is a variable that I created to open the lecture days file, okay? And I've told you that I'm writing into that. So now I'll get that variable and put it inside fprintf, that this is where you are writing into. And what are you writing into? It is what is inside the quotation mark after the variable LEC. It could have been any variable, so you name it any name of your choice. Let it just be a valid name. So inside what I'm typing into the file, there are placeholders, right? We have talked about placeholders. The first one is a string, %s. The next one is an integer, %d. Then the other one is float. So I'm storing inside of it for the first placeholder, which is character, right? I'm storing inside of it day 1. The second one, which is integer, I'm storing inside of it t1, which is actually an integer, right? Then the next one is also a character, and the last one is a floating number. Okay, so in that order that I've positioned the placeholder, that is the same order that I will put the variable that I'm passing into the printf. Then once I'm done, I will close the file. So let's implement that. With that explanation, implement what I've said right into a file. So if that file does not exist before, by you typing lec=f_open and you put the name of the file inside the quotation, it's going to create that file for you, even if it does not exist before. So let's try that. For time's sake, I'm just going to copy what I have here and use it as a demonstration for you to see what actually happens. Notice that under the names of files that I have or folders that I have, there's nothing like lecture days there before. Okay, but if I put this command and enter, it's going to create that file. Have you seen it? And you see that it's different from the kind of files we have there before, because I told it to create a text file for me. That's why it's looking that way. So you could have said it should create any kind of file for you. So this is what I want to write into it. So having issued that command, it would have written into that file that I created. It would have written into it. So the next thing is that let us close the file. After writing, the next appropriate thing is that you close the file so that you don't commit something into it by error. So once you are done writing, you close it. You are writing into the file with fprintf command. What is inside the parentheses is the name of the variable that is holding the file that we opened, and what we are passing into the file. What is? It's a placeholder for string. Okay, there was a typo. This is supposed to be F close, not close, right? So I omitted that while copying it. So yours should be F close, not close, please. So the file is closed. Now let's open that file to view what is inside of it. What do we expect to see there? What do we expect to see inside of the file? Our lecture holds on day 1 at 9 and day 2 at 12:09. Although if it were time, 12:09 is not actually a floating number. That's not the, but let's just use that based on what we have done so far. Let's just use it as a floating number. So let me open it and let's see if we have what we expect to see. So I have opened the file that I created and you see what we have typed. Okay, so that's writing into a file. So the next thing is, let us append into a file. So this is what is there, right? So let's close. So I told you that writing into a file and appending, they are similar. The only thing is the permission. The first one you use W as the permission. The second one you use A as the permission. So let's append into the file that we have just created. So the first thing is that we create a variable that we hold the file that we are going to open. So the name of the variable can be anything of your choice. So in this case, the name of the variable LEC here. You could choose any name that is convenient for you. Then we open the file using the command fopen. Inside the parentheses, you pass in the name of the file where you want to append something. So here we want to append it to lecture-days.txt. It could be any other thing, any other file that you have in your directory. Okay. Then after that, we put a comma and put the permission. So the permission here is A in quotation mark, indicating that we are appending. So what do we want to append? We want to say on the next line, that's where we have /n, write other days of the week are Tuesday on a line, Wednesday on another line, Thursday on another line, Saturday on another line, and Sunday on another line. Then move the command icon to the next line. So that's what it means. Once we are done passing in that information, then we close the file by saying F-close. Inside the F-close parentheses, you put the variable that is storing the file that you have opened. In this case, it is LEC. So let me implement this and see what happens. We have closed it before, so we are opening it again. Now this is what we are appending into LEC, which is holding the file for us. Now that we have appended, let's close the file. So let me open the file again and see if we actually appended or not. So successfully, we have added more text to what we had. We have said other days of the week are Tuesday, Wednesday, Thursday, Saturday, and Sunday. So that is it. That's how to write into a file and to append into a file. Any question? How did I get to showing open it again? The command to open is fopen, right? You know I won't see it from there, right? So look at my own syntax. It's not showing, it's not displaying this. If you want this display, you double click on your work. But you haven't appended. Have you appended? But you want to see what you have written first. So double click on that file. And you have it.
So last place I just close that and do the extra.
And you can leave it open like that, but the command that you have used, use it to close it. Use the command to close it officially.
Is it F close there?
F close, then you pass in the name of that file, or the variable that is holding it rather. So why is it showing you that? So clear all commands, then close it at that point. Clear all of the commands that you have there. Then close. Yeah. Okay. Open the file. What do you want to do now? You want to append, right? Open the file with the command F open and all of the things that you need to put in place.
I have to write all those things again.
If you want to append. Okay, so let's move on. So let's move on to the business of the day. So today we'll be looking at array in MATLAB. So it will involve vectors and what we call matrices. I think it's safe to say that all variables in MATLAB are arrays. So that means if you have a numeric variable, let's say you create a numeric variable now, you could store multiple numbers inside a particular variable that you have created to form an array. It's allowable in MATLAB. And also, one advantage of that is that you can store similar data inside one variable in form of an array. So if you have similar data, instead of creating different variables for each of them, you could store them inside that same variable that you have created in form of an array. So when I say variables in MATLAB are arrays, so what if I just say m is equal to 3? That's only one number. So what does that mean? It means that it's a 1-by-1 array. It has one row and one column. That is what it means to MATLAB. So now let's do an example of creating an array. So let's say you want to create a variable that has 2 elements inside of it. So how do we do that? The first thing is that you provide the variable name, you put the equality operator, then you introduce a square bracket. Inside the square bracket, you introduce each of the elements that is supposed to be there. So let's create a variable x that has element 3 and 5. To create that, x equals to, you open a square bracket, then you pass in 3, you separate it with space, followed by 5, which is the next element. Can you do that? Did it create an array for you? So you notice that the element inside your array is separated by space. So this kind of array is called a row vector. A row vector. It has only one row and has two columns. But the data is being presented in row format. So it's a row vector. So we can call it a 1 by n matrix. One row and n columns. So in this case, the value of n is 2. Now, instead of using the space, you could have used comma also to produce a row vector. So it's still going to give you the same output. So instead of the space that we had, let us edit it. Let's fetch our x and let's edit it. Let's remove the space and replace with comma, and let's see what actually happens. You see, it's still the same result. So that means space and commas, they produce row vectors. If you want to produce a column vector, what you need to do is the elements should be separated by a semicolon. So if instead of comma we use semicolon, then what we are going to have is going to be in column form. So instead of x being a row column, let us get it and make it a column vector. So you replace your comma with a semicolon. So now the data is presented in column form. So we can say this is a column vector. It has n rows, n by 1 is an n by 1 vector. It has n rows and 1 column. N here is 2. So this is n by 1 vector. Now let's see another way of creating a vector. So let's create a variable x that has 7 and 9. That has 7 and 9. Yeah. And let it be a row vector this time around. Let it be a row vector. So let's say z. Did we say 7 and 9? 7 and 9. Okay. So this is a row vector. But let's say we want z to be column vector. So you could do it like this. You could say your z equals to then you introduce apostrophe. Yeah. So that apostrophe is going to make a row vector to become a column vector. So by using apostrophe, you can convert a row vector to a column vector. So that apostrophe can be called the transpose operator. Transpose operator. So that's the official name for the apostrophe. So moving ahead, let's create a vector v that has this element 1, 4, 7, 10, 13, and let it be a row vector. Do you want to try that? You want to create a row vector named v and has elements 1, 4, 7, 10, and 13. Do you have it?
Yes.
So let's create a column vector W from V. From V, create a column vector and name it W. Do you have it? So that means you just have to transpose so that gives you that. But instead of doing it stepwisely, you could have done it once. So what you just do is, whatsoever you will eventually transpose, you could have put it inside a bracket so that it does the operation inside the bracket first, then you now transpose. Let me show you an example. Okay. So let me say my Z is equal to, let me open a bracket, and inside of it I have a list which is 1, 2, 1, 2, 3. So I have a list inside of it, 1, 2, 3. Instead of calling it Z, let me call it T. So that list is inside of the parentheses. So that means we are going to create, the computer is going to create that list first. Then if I now put the apostrophe outside, then immediately after creating the list, it's going to transpose it. So let's see if that works. I hope that you get the logic.
Yes, ma'am.
So instead of doing it in a two-step, you could have enclosed the list inside a parenthesis, then you transpose. So it would be nice that if you have a vector, that you are able to refer to any of the elements inside of it and be able to do some necessary modification to it if you need to do it. So that leads us to the concept of index. So you want to know what is the index of the elements of your vector. So if you type something like V and open a parenthesis and say 1 column symbol and 3, if you type that 1 column symbol and 3, it's telling you that you are accessing the first element to the third element of variable V. We had created variable V earlier. So by opening a bracket just after the V and typing in 1 to 3 or 1 column symbol and 3, you are saying, help me bring the value from 1, the first element, to the third element. So you might want to run that and see what it returns to you. So it has returned the first 3 elements of variable V to us. So that's the way of accessing the elements of a vector. So the first element is indexed in 1. Now the very last element, you can say it is indexed in end. You can call it end. That's the index for the last one. And you can use the number. Let's say you know the number. Maybe it's 1. Maybe there are 20 elements, so you could say 20 for that index, or you could just say end. Okay. So now let's say we want to create a list, which is a subset of V, and that list is going to contain the second element of V and the last element of V. So you can just introduce the square bracket, which is showing that you want to create an array or a list. Then what are the elements? the first one in this case is going to be the second element of V. So that's why we have V of 2, comma. You know, we use comma to separate list for a row vector. So maybe in this case we are creating a row vector. If you don't put comma, we could have put a space if we are looking at a row vector. But if what we are creating is a column vector, instead of that comma, you introduce a semicolon. So what's the next element? The next element is the very last element of V. So we say V into bracket end. So that will return the second element and the last element of V. Any return for you? Okay. So we use column symbol just before now to specify the range of the element that we want to pick. So it was a continuous consecutive element from this point to this point. Okay. So we could also use, if you are specifying column alone, working with a vector. So you specify the column alone inside the parentheses. What it's going to do is that it's going to extract all of the elements inside that variable and return it to you as a column vector. So V was a row vector now. So if after the V you open a parenthesis and put in column, what it's going to do is that it's going to return a column vector, which is the element of V that you had before. So can we try that? So that means instead, the other time when we wanted to convert a row vector to a column vector, we use apostrophe. So there are many routes to doing anything that has to do with programming. There are many routes to it. So this is another route for converting a row vector to a column vector. But if however we type something like 1 column end, you know, we specify something before the column and we specify something after the column. So what is going to return to you is still is going to be a row vector, because you specified something before and you specify something after. So you already know that end in this case is telling you that the last element of variable V. Okay. Then column in this context is saying from this range to this range. So we are learning how to speak MATLAB language. Like we have present, we have present. So what it means is going to be contextual, right? So in the same way, column, which is our focus this time around, what it means is going to depend on how you are using it. The usage will determine what it does for you. Even present can have more than one meaning. It could be that you are here, it could be that it's a gift. And if you see present, it's still the same spelling. But what they do will depend on the context. So the same thing in any programming language, and our focus here is MATLAB. Whatsoever you see, the meaning or what it does is contextual. So this gives us a range of elements, the first element to the last element of V. And this time around, it's coming out as a row vector. So if I have a particular element, let's say the second element now, I discover that what's the value of the second element of V? What's the value? The second element of V is 4. So let's say that you discover that that element should not be 4 and should be another number, say 11. You can correct it. by accessing that particular element and equating it to the value that you think it should be. So let's do that. So we could say so V, you specify which of the element of V by opening a parenthesis. So inside that parenthesis, you tell us the location, the index. So this time I want to change the second element, so you pass in 2. So let's make the second element equals to 11. So press enter. So you see it has returned array V. However, that 4 has been changed to 11 as we have asked it to do. So that's how to change or to edit the value of an array. So now let's move to matrices. So when we talk about matrices, you know matrices, we have rows, we have column. Okay. So we said scalars is also an array, but it has only one row and one column. Then we have vectors, the row vectors and the column vectors. For the row vectors, it has one row and n numbers of columns, depending on the length or the number of elements. Then also we have the column vector, which has n numbers of rows and one column. N number of rows will depend on the number of elements that is inside that column vector. So there are special cases of matrices. So any matrix that has maybe one row or one column, but has maybe several columns, and maybe it has one row and several columns, or it has several rows and one column, they are vectors. But once the number of rows and the number of columns is more than 1, then that's a full-fledged matrix. Okay. So in this outline, we are using M to represent rows, and we are using N to represent column, except I say otherwise. Okay. So now we've seen how to create a row vector. How do we create row vector? We separate it by space. So to create a row vector, we use space or comma. But if we want to create a column vector, how do we create that? We use column. So that means if you want to create a matrix, we can use the combination of space and column. So that means you list your element row by row. Once you are done listing the first row and you want to move to the next row, you put a column so that another row begins below the previous one. So it's a combination of space and semicolon that you use to create a matrix. So let's say you want to create a matrix called X that has in row 1, 3, 4, 5, and in row 2 it has 6, 7, 9. So what you need to do is that now this is an array. The first thing is that we need a square bracket, and inside the square bracket we put in the elements. So what are the elements? You produce the element of row 1 first, you supply that one first. Once you are done, you put a semicolon, then you put the element of the next row. So let's try that. So it's going to be 3, 4, 5, semicolon, and 6, 7, 8 to produce the matrix that we are looking for. You might not use comma, somebody might use space like I've used in the lecture note that I have here. You may want to try that also, and let's see what your output looks like. Okay, so I have my matrix on the board. change, right? I wanted to see if it will be bigger on the screen for you to see better, but I see there is no change in the size. So let me return to what it was before. Okay, so we have created matrix X. How many of you were able to create that matrix? Okay, so let's move on. So can we create matrix C? Let's create matrix C. So that's the content of matrix C. That was too quick, right? I haven't completed my data set. Have you created the C? Okay. So we have that. So let's see what we can do with it. So you want to get what is the size of a matrix. There is a function called size. So size can return to you the number of rows, the number of columns. Okay, so already how many rows do we have here for C? 3 rows and how many columns? So if you type size and pass in C as an argument, it's going to return 3, 4 to you. Okay? But you want to give name to each of the values. You know your row comes before your column. So you can say in front of it, you are creating a kind of list by putting a square bracket. So you are separating the list M, N. Okay? So the value of the size of C is now going to be stored inside those variables that you have created. So it's going to return the value of M and the value of N to you. Okay, so it's telling us that M is 3, that's our row, and N is 4. Now, when we looked at vector, we looked at how we can access each element of a vector, right? Did we? And we saw how we can maybe edit it if there is a need for it. So in the same way, how do we access the element of a matrix? So for a matrix, you know that each element is described by its row and column. So if I say we have a variable x now, let's say we have a matrix x, Do we have a matrix X? Yes, we have a matrix X. So if I open a parenthesis after I type X and I pass in two values separated by a comma, so it's going to interpret it as M, N, that this is the row, the first value is the row, the second value is the column. So it's going to pick the element that is occupying the second row and the first column. So by visualization, what's the element occupying the second row and the first column? X. This is my own X here. So what's the element occupying row 2? Where is row 2? This is row 2. Column 1. So 6 is the element occupying that space. So if you run this code and say X into 2, 1, it's going to pick the element that is at the second row and the first column. So it's returning 6 to us as the answer. So we said we can use end to refer to a location which is the last in that maybe series. So if I put end, 2, it's telling me that the last row followed by second column, row, column. So it's saying if I have X into N, 2, it's saying go to the last row, then the second column, and get what is there for me. So still working with X. To verify our result before I run that code, let us go there. So we just have 2 rows here. So that means the second row is the end of the row. Then the second column on this last row. So what is there is 7. So let's run this code that I've just copied. Let's run it. So that returns 7. So with end, you can do some arithmetic. So you can say n minus 1, n minus 2, n minus anything. Okay. So you can use n as a reference point. So what we are saying is that just same way we could access the elements of a vector, we can also access the elements of a matrix. However, this time around, we will need to supply the elements row and column. So the elements row will be separated by a comma to give the address of the particular element you are referring to. Then I also said we could do calculations using end. So you could use end as a reference point and deduct some numbers from it to specify what location you are looking at. So we have a matrix C. So if we supply C and open a parenthesis and put in n minus 1, n minus 2. So it's going to pick the element that is in the last but one row, and on that row, on column n and but 2. So let's run that and let's see what it returns to us. So it's returning 10. So let's see, this is our C, matrix C here. So if we go to n minus 1 row, it's just 3 rows, so that means it's referring to row 2. And on that, we are going to column n minus 2. So this is n minus 1, this is n minus 2. So 10 is what is at that address. Accessing elements of a matrix, you need to specify the row and column. We know what end means in terms of reference. So look at the code that is highlighted on the notes. So what does n minus 1 mean? So So the order of specifying the location is row, comma, column. So the first one, end minus 1, what is it referring to? So what does end mean in this context? The last in the series. So the first argument you give to it is going to be row. Its row order is row, comma, column. So n minus 1 is referring to what? It's referring to the row. N minus 2 in this case is referring to the column. So what is end? End of what? The end in the series. So we are talking about row now. So the last row. So from the last row, remove 1. Is what? How many rows do you have? 3 rows. So row 3 is the end of the row. So remove 1 from row 3. So that's, we are talking about row 2. So use that interpretation for the other one. So what are we talking about in the column? So end minus 2, what are we actually referring to? Look up. End minus 2 is referring to what? The column location. So end of what? End of what? End of the entire column. So what is the end of the column? How many columns do you have? 4. Remove 2 from 4. You are talking about the second column. So now combine it. End minus 1 is talking about the row. So what row are you going to? Row 2, column 2. So can we get row 2, column 2? What's the member? That's the element there is 10. So that's why it's returning 10 to us. So the ideal way is to supply what is the row and what is the column. But if by adventure you just supplied one value, instead of supplying this is the row, this is the... So what it does is that whatever value you give, MATLAB is going to transverse it vertically. Okay? So it's going to look at what's in column 1. Okay? So the first element in column 1, it takes it at 1. The second one, column 2. The second element, it takes it at 2. The third one, it takes it at 3. So once it's done with the first column, it moves to the next column until it gets to the number that you have supplied. So this time around, let's create a matrix called A with the following elements. So matrix A has 1, 2, 3 on the first row, 4, 5, 6 on the second row, 7, 8, 9 on the third row. So let's create that matrix. So you see the way it's looking like, right? So if you pass A into 3 as a command, so what is it going to return? It's going to return 7, because what it does is that it starts with the first column and labels it one after the other. So the third element on that column is 7. So if I had supplied A of, let me say A of 8, what do you think is going to return? It's going to return 6. So that's the way MATLAB interprets column by column. It counts the first column first, counts the second column next, until it gets to the last column, or until when it reaches the number you have specified. So even though when you want to enter your element for a matrix, you enter it row-wise. You input the element of the first row, semicolon, you move to the next row. But when MATLAB wants to process it in terms of indexing, it does it column-wise. So if you are specifying an index for a matrix, if you have not supplied the row and column, and you just give a number, it's going to process it for you column-wise, from the top to the bottom. So we have seen that we can use column symbol or column operator to refer to range of values or range of locations. So if you have something like A into brackets, R column S, comma, K column L. If A is a matrix, so you know the first part that was separated by a comma is going to refer to the row. And the second part is going to refer to the column. So what that is telling you that we are trying to extract rows R to S. We have several rows, but now we are interested in rows R to S. Then in terms of column, we are interested in column K to L. So K can be any value, L can be any value, R can be any value, S can be any value. But one thing you should have noticed is that when we are using column to represent range, that means they are continuous. That means there is continuity. So as an example, let me pick rows 1 to 2 for A, rows 1 to 2, and then column 2 to 3. As an example, let me have this. So from matrix A, I want to create a submatrix which entails row 1 to 2. Row 1 to 2. And for the column, let the column be 2 to 3. So I'm extracting column 2 to 3, row 1 to 2. So let's see what it brings out. I hope you get how it works now. So it has gone to row 1 to 2. So in row 1 to 2, this is row 1, this is row 2. But I also streamline it by saying in row 1 to row 2 that I'm looking at, let us get only column 2 to 3. So this is column 2 to 3. So that's why it's bringing this out as a submatrix of A. I hope you are getting how this works. Can we move on? Is that clear, or you have a question? Okay. Yeah. 1 to 2. Whatsoever is there, that's what it's going to bring out. So I said the first part before the comma is what? Your row. So it's what? Based on what we have input, is what? Row 1 to 2. Then the balance of it is that which of the columns, are you working with all of the columns or part of the columns? So this question says we are working with columns 2 to 3. So combine it. look at it. What are the errors that can be there? Carefully. There can be some subtle error. What? The columns, are they counting from bottom to top? Okay, so the way we work here is the first element is 1. The next one is 2. Okay, so if you just say 1, 2, 3, so that means it's going to start if it's about row. So the top row is your row 1, the second row is your row 2, and so on and so forth. If it's column, if you are starting with 1, 2, 3 and you are using number, so it's going to start from the left and move rightward. If you are using something like end, you have to know where the end is. And if you are subtracting anything from the end, so that means you are moving from where the end is. So for column, it's going to be from the right if you are using end. If it's row, if you are using end, it's going to start from the bottom. So you can write it down. I think it's helpful to have a good note for this class. So as you have the matrix, what you can do is you put a circle around the one that you have noticed, like we said, row 1 to 2. If you circle it, then you now circle out column 2 to 3 to help you visualize it, to understand what is actually happening. So let's move on from there. Now we said when we use column alone as standalone, if column is standing alone, so it's going to access everything in that range, everything that is there. So now for accessing elements of matrix, we said we need to provide what the row is and what the column is. So if you look at this expression that says small letter a is equal to capital letter A into column, comma 1. Column, comma 1. So column precedes comma, but that column is standing alone. So it's telling you that we are looking at the entire row in that matrix, capital letter A. So everything that is a row counts there. But what column are we looking at? We are looking at what column? Column 1. So it's telling you that what we are looking at is the result should be a column matrix that encompasses all of the elements in that comprises all of the rows. So if you had, let's say, 5 rows, so the expectation is that we have a vector matrix which is 5 by 1. If you had 3 rows before, the expectation is that it's going to return a matrix or a vector that is 3 by 1 to us. So that column, what I'm saying is that that column, it accesses everything within that range that you are looking at. So in this case, we are looking at row because row comes before the column. So in this case, if you run this code, what do you think the elements are going to be? What do you think the elements are going to be? This is matrix A. So what are we expecting? 147. So now you understand it. 147. The second code, if you run this, what do you think we have? What do you think we have? What do you think we have? What's that saying? We said 2 to end. So the first thing you want to know is what is our end? How many rows does A have? It has 3 rows. So we are saying 2 to 3, row 2 to 3. That's that part. Then the column part is talking about what? The 3 columns. Okay, the 3 columns. So what do we think we should have? Yeah. So that's it. So let's look at let's create a matrix called B. So a matrix called B is going to be a subset of matrix A. So what do we want for matrix A? We want for B, for matrix B, which is a sub-matrix of A, we want elements that are in the 2nd and 3rd row. And we also want that element to be element of column 1 to 2. So we could have used, instead of that square bracket, we could have used 2 to 3, yeah, comma what? 1 to 2. Okay. But there is a reason we are using this approach. We'll get to that after now. So this approach is still going to give us what is going to be if we have typed A into 2 to 3, comma 1 to 2. By that I mean the column operator, right? Okay. So before we know, you see there is a comma somewhere. So that comma is divided it into 2 parts. So the first part is what? So what does that mean? What is that referring to? Based on the comma separation, row, that's talking about row, and the other part is talking about column. So you have 2 and 3 inside a parenthesis, right? Square bracket. So it's talking about 2nd and 3rd row. So what's the other part talking about? Okay. So I said, using that style will give us the same results if we had said A into 2 to 3, comma 1 to 2, like we have done previously. But why are we introducing that style? So let's say what you want to extract is not, let's say, sequential like that. So let's say you want to extract row 2 first, followed by row 1. What was in row 2 before? You want to make it row 1, and what was in row 1 now you want to bring it to row 2. So you know 2 to this will not work in that situation because they are not sequential like that. So that is why we introduce that square bracket. So for example, let's say we want to extract what is in row 2, followed by what is in row 1, followed by what is in row 3. So you have to use the square bracket to show the order at which you want to extract it. So if you look at this now, so what it's saying is that you are creating a submatrix from A, and that submatrix has the 2nd row of A first, followed by the 1st row of A, followed by the third row of A. Then all of the columns, every column should be represented because the other part is saying comma column. So that means everything. So let's run that and let's see what the output looks like. So A had 3 columns. So you see that all of the columns are there. Okay? And what is now different is that in C, what used to be row 1 in A is now row 2 because of the way we ordered it. Okay. So that is what it is. So just like we did when we had vector, that we passed column alone inside the parentheses and it extracted everything that is there in form of a column vector. So you can also do that for matrices. So we have matrix A. So if you say A into column, so what it's going to do is that all of the elements inside A is going to be listed as a column. And how does it list it? It lists the first column first because that's the way it works. Move to the next column until it gets to the last column. So let's run